All right, Mr. Ahmed here for 1.3, part 1. In lesson 1.3, we're going to talk about midpoints and segment bisectors. So we're still working with segments. A couple definitions to start things off. The first one is congruent segments are two or more segments that have the same length. So example, AB could be 10, CD could be 10. If they were both 10 feet long, they would be congruent. They have the same length. The way we indicate that segments are congruent in a diagram is by using tick marks. You'll see these quite frequently. If you see a segment with one tick mark and a segment with another tick mark, that indicates that those two segments are congruent. It isn't breaking the segment apart, just one tick, that means they're the same size. You might see a different diagram where we would have, I'm just going to draw another example here right above it. So if I have this segment here and this segment here, just two random ones, if they both have two tick marks, that means those two are congruent to each other, but they are not necessarily congruent to the ones that only have one tick mark. When I name congruent segments, I would say that AB is congruent to CD. When I say they're congruent, the segment signs need to be above them, and I use a congruent sign. A congruent sign is an equal with a squiggly above it, okay? If I say that they're equal in length, all right, congruent and equal are very similar, however, they are somewhat different. Congruent is talking about the actual segment. Equal is referring to their length. So if I write an equation, I could say that AB is equal to CD. That means they are equal, and I could start solving. I can't really solve a congruent statement, but I can solve an equation. Midpoint. A midpoint is the point that divides a segment into two congruent segments, so it's halfway. In this diagram, we're missing a little bit of the piece here. It appears as if it got chopped off a little bit in this photo, so unfortunately, we are going to have to add in another point and rewrite this equation because it looks like this on all of your sheets, so I kept it that way. So it says M is the midpoint of AB. M, midpoint A, we are missing point B. Add point B right here. So I could say AM is congruent to MB, and AM is equal to MB. Okay, so when I say they're equal, no segment sign. When I say they're congruent, there needs to be a segment sign. So named, just one more time, AM is congruent to MB. And I could also say AM is equal to MB. All right. Moving onward. A segment bisector is a line, could be a line segment, could be a ray. It's really anything. A segment bisector cuts a segment in half. So it cuts it into two equal parts. Bisect means cut in half. So again, this diagram a little bit got chopped off. So it says CD is the segment bisector of AB. So I need to add point B here again. A to B. And named AM is congruent to MB. Notice the tick marks show that AM, same length as M to B. And I could also say that AM is equal to, that's not an A, AM is equal to MB. All right, so key points here. Midpoint divides a segment in half. Bisector cuts a segment in half. The only difference between the two is the bisector could really be anything, but a midpoint has to be a point because that is the halfway point. So a segment bisector goes through a segment at its midpoint. All right, so hopping into some examples here. Again, as I solve for variables, I am going to set up an equation just like we did with the segment addition postulate. We need to figure out what's equal. So the problem tells us point Q is the midpoint of PR. So Q, midpoint of P to R, that means PR is cut in half. PQ is congruent to QR. I want to put those tick marks in my diagram, so if I have to find more information, I can just look and see, oh, these two parts are equal. So now I can set up an equation since I know it's equal. PQ is equal to QR. You do not need to write down the notation. You could skip this step. You don't need to write this one. You just need to say 9y minus 2, which is PQ, is equal to 14 plus 5y. Those are the two parts that are equal. Now from here, we are going to solve. So 9y minus 2 equals 14 plus 5y. And when I solve this, I think I'm going to subtract 5y first. So I'd have 4y minus 2 equals 14. At this point, I'm going to start skipping some steps in the equation. I'm adding 2 for y is equal to 16. Divide, and y is equal to 4. Now, the question doesn't only ask us to find y. It asks us to find PR. So I need to substitute y back in. So I can only put it in for PQ or QR, but keep in mind those are the same length. So I'm going to put it in here first. 9 times 4 gets us 36. 36 minus 2 is 34. And in a similar manner, if I put it in here, 5 times 4 is 20 plus 14. This part's also 34. So the entire length, 34 plus 34 is 68. So PR is equal to 68 units. Had to add up the two pieces. 34 plus 34. All right, next example says B is the midpoint of AC. We need to find BC. So since B is the midpoint of AC, that means these two lengths are equal, AB and BC. I know AB is x plus 6, therefore BC is also x plus 6. Now I can set up my equation. If I just say x plus 6 equals x plus 6, I'm going to get everything to cancel out and get infinite solutions. That's too obvious in nature. I can't set it up that way. I need to look at the entire length. The entire thing is 3x minus 31, and that's equal to the two parts added together. X plus 6 plus x plus 6. That's where you need to start. I'm going to write out the notation as well. The entire segment AC was equal to AB plus BC. You don't need to write out the notation format. Now we'll solve. 3x minus 31, no like terms on the left, equals 2x plus 12. Round them up. Subtract our 2x from both sides. X minus 3 equals 12. Add 3, x equals 15. What are we supposed to find? We're supposed to find BC. Have to put x back in for BC. 15 plus 6 is 21, so BC is equal to 21 units. We do not have anything there, so just 21. All right, moving on to our next page. A couple more things. First thing says to identify the segment bisector, then find MQ. So the segment bisector in this case is line L. The reason why I know that's a segment bisector is I see the two tick marks. These two segments are marked as congruent. So line L is the segment I'm abbreviating bisector. All right, now setting up my equation. That means PM is equal to MQ. 5x minus 3 is equal to 11 minus 2x. Now from here, solve the equation. Add 2x to both sides. 7x minus 3 equals 11. Add the 3. 7x equals 14. And divide, we get x equal 2. So I'm going to start solving these equations a little bit quicker because we've practiced solving equations already. We are supposed to find MQ, so we have to put 2 back in. So that would be 11 minus 4. 2 times 2 is 4, and we get 7. So MQ is equal to 7 units. All right, next example says, AB bisects CD. So that means AB is cutting CD in half. That key word there, bisects, got to find it. Mark it. C2, I don't know, whatever point that is congruent to this part. Put the tick marks on the diagram. Those are the two equal parts. Setting up my equation, the two things that are equal is 2 times 3x plus 5 is equal to 4 times x plus 6. Now we got to solve, distribute. 6x plus 10 is equal to 4x plus 24. And round up the x's. I'm bringing 4x over, 2x, subtract it, plus 10 is equal to 24. 2x equals 14, and x is equal to 7. What were we supposed to find? Had to find CD, so I have to put x back in. So let's see here. Let's put it in here. 7 plus 6 is 13. We have to take 13 times 4. 13 times 4 is 52. So that means this part's 52. They are equal, so this is also 52. The entire length CD is equal to 52 plus 52, which is 104. Circle in my other answer. All right, last example here. It says AB and CD bisect each other. So if something bisects each other, that means that both segments are cut in half. So I know that CD is cut in half. These two parts are equal. And I also know that these two parts are equal. All four are not equal to each other. Let's see. I'm also told that C to D is 16. So if CD is 16, that means that this little part is how much? Half of 16. That means it is 8 and 8. So for me to solve for y, I'm going to say that 3y minus 1 is equal to 8. Add 1, 3y equals 9, y is equal to 3. So I found y. I need to find x. So for me to find x, we have to substitute what y is back into the original problem. And 6 times 3 is 18 plus 1, that means 19. This part's 19, so this part's also 19. Set up one more equation. 4x minus 29 is equal to 19. Add the 29 to both sides, and we get 48. 4x equals 48. Divide 4, and our final solution is 12. That was a little bit of a challenging one, and that wraps us up for today. Have a good one.